Hi, welcome to this channel. In today's video, I'll be continuing from where I stopped in the last class. In class, I promised that I will try as much as possible to make this tutorial series a pure practical series and all the approaches be practical as possible. But before we go into anything practical, there are some basic concepts we need to understand. In fact, before you get into any form of design, graphics design, architectural design, you have to understand the concepts that guide the designs. And so today I'll be introducing us to some of the concepts that will be needed as we proceed in this class. You have to understand electronics quantities. In the financial world, you must have come across some terms, some quantities that are used. For example, currency, debts, and I'm not really a financial person, but there are some quantities that are used in every field that makes one understand what he is talking about or what he's doing. And so in electronic design, there are some quantities that are very important. I want to beg at this point, please pay rapt attention, because once you understand this once and for all, it guides you to understand some other things as we proceed. The first one is going to be voltage. Understanding what voltage is. I'm sure many of us might have heard of what voltage. You must have heard people use the word voltage as one point or the other. But voltage is just referring to the pressure or the force from an electrical circuit's power source. That means the pressure or the force that comes out of a battery, as it's seen here, a battery, that pushes charged electrons. Those charged electrons are referred to as current. So that force that pushes those currents through a conducting loop, that's a closed connected wire system, through a closed loop, a closed connected wire system, that force that pushes electric charge with the primary purpose of doing work, enabling them to do work, such as illuminating a light, maybe rotating a fan, buzzing a siren, or whatever. So far a force is brought out of the battery to push electronic charge to do work, that force is referred to as the voltage, and the unit is volts. Now in electrical design or electronics design, we will be referring to some quantities by their units. Their unit is just the measure, is like an evaluation of the magnitude of that quantity. So here voltage is seen as volts, is the unit of voltage rather is volts. So I come again, voltage is just talking about that force you apply, or that force that pushes electrons or electric charges out of a power source, could be battery or any other power source, enabling them to do work. Of course, you know the work is to illuminate a light, to rotate, just to perform one electrical work or the other. That is the voltage. I'm going to give a very more detailed explanation in other slides, but for now I think this is just a good summary of what voltage is talking about. So please understand what voltage is, so that I've noticed that so many people mistake voltage from current and current from voltage and all. It's good to really understand. The next quantity is current. Now what is current? Current is the rate at which electrons flow past a point in a complete electrical circuit. An electrical circuit is a complete connected system, electrical connected system, or electronics connected system. But current is the rate at which the electrons flow from one point to the other. That means the current at this point may be different from the current at this point based on the system, based on the circuit, but the speed at which it flows at this point is the current. So remember in our previous definition of voltage, we talked about flow of electrons, pushing electrons. Now those electrons keep flowing at a rate. The rate at which those electrons flow in the entire system is what requires current. The unit of current is amperes. It's usually denoted with the symbol capital letter I. So as we proceed, you will have a better understanding, but get this concept once and for all, that current is talking about the rate of flow of electrons in a circuit. The next quantity is resistance. Resistance. The electrical resistance of an object or electronic component is a measure of the opposition to the flow of electric current. please take note of this: opposition to the flow of electric current. Remember, when we're talking about voltage, we talk about voltage as being the force pushing electric charges. Now resistance is an opposition. So a force is pushing this way, resistance is talking about, should I say, another system pushing it back, resisting it. So that's just all you need to know about resistance. It's an opposition to the flow of electric current. The unit of resistance is ohms and is denoted by R. Now in the next slide, I'll give a very good illustration of what those three quantities really mean. There are more electronics quantities that we need to talk about, but for now we'll just limit ourselves to these three because they form the basic quantities that are used by all electronics engineers. Very important. Those are the basic quantities. Now you can see at this point, this man here representing volts, that's the voltage, is applying a force to this other man here representing the current. So it's pushing this current, it's pushing the current through this part or through this medium. It's pushing through this part, that's through the wires. Let's assume this medium or this part is the wire. So the force from the battery is pushing the current through this part. But this other man here, who is the resistance, the ohms, the resistance, is trying to oppose the flow. So imagine if this man here was stronger than this man, that means it will be difficult for this current to pass through this medium because it's going to resist him totally. But if this man is stronger than this other one, is still going to be able to overcome this resistance and allow current to still flow through the medium. And whichever way, we just have to understand that voltage is talking about the force. The current is actually what is being pushed. That's electrons, the electric charges that are being pushed in the system. Why the resistance is the opposition, trying to resist the flow of electrons. I think that's just a simple illustration. Now, there's something we need to talk about that is very, very important: Ohm's law. I said before that before you can begin to build different designs and get your hands into building, you have to understand this concept. They are very important because they will be very useful as we proceed in this course. Ohm's law. Ohm's law in essence is just saying voltage is equal to current times resistance. So the voltage, the force we explained before, is actually equal to the current times the opposition, the resistance. That's just all Ohm's law is trying to say. And it's the same thing as V is equal to I times R. So mathematically, this is the representation. Now this implies that if V, which is voltage, is equal to 9 volts, let's assume we have a 9-volt battery, a battery that is rated 9 volts, and R is equal to 1000 ohms. So we have a resistance of 1000. Then I, making I the subject of formula from basic mathematics, we mean that I will be equal to V over R. That's correct. Then I will be equal to 9 divided by 1000. And that's equal to 0.009 amps, which is same thing as 9 milliamps. In electronics designs or in engineering generally, when we divide any unit by 1000, it becomes milli. So this 0.009 amps divided by 1000 becomes 9 milliamperes. So just understand that all I did was just to divide it by 1000 to make it 9 milliamperes. 9 milliamperes is something as 0.009 amps. So that's just a subunit of amperes. So you can see that when we had a battery voltage of 9 volts and the resistance was 1000, we were able to get 9 milliamperes. But if we still have another voltage, another system where the voltage is 9 volts still, but the resistance is 220 ohms. Now you can see this 220 ohms is far lesser than 1000, but same voltage. You see that I is equal to 9 over 220, and that's 0.041 amps. That's 41 milliamperes. We had high resistance here, we had lower current, 9 milliamperes. But when we had lower resistance, more current was able to flow because the resistance was lower, and we have 41 milliamperes. So I think this illustration explains Ohm's law and also explains the three concepts I've been explaining so far: voltage, current, and resistance. If you are finding it difficult to understand, I beg you, go over this course again, this particular video, because a good understanding of this concept is going to guide us as we proceed. Now, before I end this class, I would like to talk about something: safety. As we advance, we will start working with some more high voltages, alternating current and voltages. Don't worry, you understand that as you proceed. So in anything you are doing, safety is very important. We are going to work with electric systems. To avoid shocks, electric shocks, you have to be safety conscious. You can read so many other textbooks or materials on safety. Even the concepts and the quantities I've explained so far, if you want to get some more explanations, you can read some other textbooks and some other articles on those. But safety is very, very important. I'm sure you enjoyed this video just as I enjoyed giving it. I would like you to kindly subscribe to this channel, hit the bell notification to get notified whenever I drop new video. You can like the video. Then one good thing is to share the video with your friends, because when you share the video, it makes it easy for you to learn alongside your friend and to collaborate. That way it aids your learning process. I am Oluwole Daniel. See you in the next class. Thank you.